Hey, what's up everyone? So it seems like yesterday we were unable to get to 2-110, so I'm going to go ahead and review that real quick. So if you could open up your books to this section, we can go over 2-110, which will introduce the Side-Splitter Theorem for us. So if we look at part A, it says for the diagram at the right, Cameron wrote the equation 4 over 6 is equal to 5 over 5 plus x. So it looks like he's using this little triangle right here. So basically we're being asked, is he correct? And ultimately I think we're going to find that he is. But remember, I always try to re-emphasize that if you see a triangle within a triangle like this, and again, there really are two triangles here, right? Sometimes it helps, especially if you're a more visual person, if you kind of draw out both triangles independently of each other. So if I make this the large triangle and I make this L, N, and J, and then if I make the smaller triangle, if I make this E, and then A, and then J, right, what we'll find is that on the smaller triangle, this side is 5, this side is 4. Now, biggest mistake you're going to make is you're going to think that this is 2, because of course it would be, right? It's this small piece down here. But remember, only AN is 2. But if we're going to do the large triangle, it's going to go from J all the way to N. So what we really have is 4 plus 2. That stands to reason as to where this number 6 is coming from. So here comes 6. And then again, this side here, just the same, is not x. It's rather 5 plus x, right? Because again, I'm taking the whole thing right here. All right. So again, if we just compare corresponding parts, I think we're going to, if we go from small to large, we're going to get 4 is to 6, as looks like 5 is to 5 plus x. So in the case of A, we can say yes, he is correct, or his equation is correct, right? Moving on to part B, it says Janelle wrote the equation 4 is to 2 as 5 is to x. Now if we solve for x here in both scenarios, I think we might end up getting the same thing. If I look at this, and I do want to kind of go over this because I feel like people are going to kind of robotically do it. So let's go ahead and just solve for x, just to make sure that we got it. I could cross multiply off the bat. I'm going to do something in between first. This 4 over 6 here can reduce to 2/3. That just makes the problem just a little bit more manageable. So 5 over 5 plus x becomes our ratio. So here we go, cross multiplying. I get a 15 equals, now again, guys, don't make this mistake. It's not 2 times 5. It's 2 times the whole thing. So 2 times 5 plus x. And then from here, I feel like we're going to get a fraction as our answer, not a big deal. 15 equals 10 plus 2x. By subtracting 10 from both sides, you get 5 equals 2x. So if you divide by 2, x equals 5 halves. So again, this is Cameron's answer based on this longer version of the equation. Now, we did that so that we could verify Janelle's work here, and she said she ended up getting the same answer, so let's we can see if she is correct. Again, just like I did with Cameron's, this 4 over 2, I could work with it if I really wanted to, or I could identify it simply as 2 equals 5 over x, right? Technically 2 over 1, and if I cross multiply, 2x is equal to 5. Hey, I'm sensing a very familiar position that we were in just a few seconds ago. A little bit of deja vu, a glitch in the matrix is coming up. 5 halves is, in fact, the answer either way. Now, I don't believe this is a coincidence. I believe this was, in fact, meant to happen, because if we look at part C, Cameron then asks Janelle, will that always work, and can we prove it? He draws a figure to the right. What information should he add to the diagram, and what does he need to prove? So in order to do that, I'm going to go ahead and cut and paste this next diagram into the black space here, and then I will be back in just a second. So take a second. If you need to pause, go ahead and pause so that you can copy all of this down, or rewind it so that you can see the explanation one more time. I'll be back in a flash. Alright, here comes part C. We are going to find out from the diagram on the right side what info does Cameron add to or does he need to add to his diagram, and what does he need to prove? Well, a couple things. One, a triangle within a triangle. That means that the triangles are going to have some similar features here. So I'm going to go and just change colors here. That way we can identify these things. Hopefully it makes sense that because the triangles are in fact similar, that means that the angles will all be congruent, right? And so what we can establish here is that angle B should be congruent to angle D because they're corresponding angles, right? And what we learned in class yesterday is that because these corresponding angles are congruent, we can then say that DE and BC are parallel to each other. So in this case, what Kamran needs to prove, and he already has because of this, right? And here's the thing, this angle and this angle are congruent, and we already know that the angles here are also congruent because they're the same, right? So by angle, we have our similarity feature of these triangles here. So we can just go ahead and make the jump and say he needs to prove that BC is parallel to DE. And we have proven it, right? By corresponding angles B and D being congruent, right? And angle A being congruent to angle A, right, by a shared angle. Right? So this really is the crux of it. As long as we can prove that those two lines are parallel, then we are good for part C. He also will need to prove that somehow, and this is the case of Janelle's answer, right, that somehow, I'm going to switch back to yellow, that somehow A over B is equal to C over D. Again, that's what Janelle did, right? She just took segment over segment is equal to segment over segment. So how did that happen? Well, let me go and clear off the board real quick, and I'm going to show you guys how that was done. And we're back with a cleaner looking board. So what we're going to do is we are going to show, does in fact A over B equal C over D? There's a question mark there because we actually could be wrong. Well, here's what I'm going to do. I'm going to go and go corresponding side to corresponding side. So if I do A is to A plus B, is equal to C over C plus D, hopefully the proportions will manage each other in such a way that I will get to this. Again, I'm hoping. I got a question mark here. I'm not quite sure. Well, if we cross multiply, again, don't make this mistake, please. You'll get A parentheses C plus D is equal to C parentheses A plus B. A little bit of distribution, never hurt anybody. AC plus AD is equal to CA, but because they're being multiplied, I'll go ahead and call them AC plus BC. I think we kind of see where this might be going. I believe the ACs are going to get themselves out of there, and AD is equal to BC. So we're getting kind of close, right? So here's the thing, is that if I divide both sides by D, not A, D, what I get is if I scroll down just ever so slightly here, I will end up with A is equal to BC over D. Now, dividing by B is the same thing as multiplying by 1 over B, so I can do that to both sides. Goodbye to the B's on the right. I end up with, and I apologize for the circular motion of the problem here, but A over B equaling C over D, and boom. Somehow this ends up becoming like that. And that is where the side-splitter theorem, bam, that's where that comes from. Okay? So it says, if a segment intersects two sides of a triangle and is parallel to the third side, right? So we have that here. I apologize for the wavy motion of this. Intersects two sides of a triangle and is parallel to the third side, right? So we qualify both. We are intersecting two sides of the triangle. we are parallel to the third side, then we can say that the lengths of the parts are proportional. A over B is to C over D. So that's where the side-splitter theorem comes from. So I apologize for not being able to get to that yesterday, but hopefully you guys get that in your notes. If not, hit the pause button, get that down in your notes in your theorem graphical organizers, and we will continue on in the next video going over some of the review packet problems.